CloudVision Universal Network Observability, or CV-UNO, helps network teams to reduce mean time to innocence when finding a root cause of an issue. In this video, we will look at how applications are discovered by CV-UNO. Arista EOS devices stream telemetry data to Arista's Network Data Lake, or NetDL, which CVAS leverages to gain visibility into the network. Now, CV-UNO provides visibility into application infrastructure to get deeper insights and end-to-end visibility for the applications. In order to do so, CV-UNO deploys a sensor in the on-prem infrastructure and collects data from various data sources like private cloud infrastructure, Arista's next-gen network packet broker, Dance Monitoring Fabric, third-party devices, and public cloud providers. The sensor curates and normalizes this data before securely streaming it to CVAS. Once all the data is in the network data lake, CV-UNO applies machine learning and its inference engine for faster root cause analysis of issues. Now let's take a look at the CV-UNO application dashboard. From the main menu, we select Applications to navigate to CV-UNO Applications dashboard, which provides insights into the application. We can see the total number of applications discovered, aggregate services, workloads, and flows for all the applications. We get insights like which applications are consuming the most resources based on CPU, memory, or bandwidth utilization. Event style displays network or application infrastructure related events that might be impacting any of the discovered applications. Application inventory provides more details for all the applications which have been discovered by CV-UNO. For each application, we get information of any active events, total number of services, total flows, and number of workloads for the application. Now let's see how applications are discovered by CV-UNO. We click on Configure Applications to navigate to the Application Rules page, where rules are defined for the application discovery. Applications can be discovered by CV-UNO manually by subnets or external labels like vCenter VM tags. In environments where Configuration Management Database or CMDB like ServiceNow, Helix, etc. are used as single source of truth for applications, CV-UNO can integrate with the CMDB via connector to discover the applications automatically. In this demo, we will discover the applications using subnet and external tags manually. To discover applications via subnet, we click on the subnet tile. The rule name for the subnet will be our application name, in this case, drawbase. Next, we specify all the services associated with the application and subnet in which each of the services reside. Once the services for all the applications have been discovered, we save the rule. We will discover the next application using external labels. We specify the rule name as ERP for this application. All the external labels used for the application in the virtual infrastructure have already been discovered by CV-UNO. For application tag, we select application with application value as ERP from the drop-down menu. Then we provide services details for our ERP application. We select the service name and the corresponding service value which has been discovered by CV-UNO from external label. For our demo, this is coming from VMware vCenter tags. Once all the service and service values are defined, we save the rule. Going back to our application dashboard, we see that the drawbase and ERP applications have been discovered. By clicking on the application tile, we can get more insight for the application. Let's take a closer look at our ERP application. Application Summary page provides a quick flow summary. Event Summary tile displays all the events associated with the application which has been identified by CV-UNO ML engine. Services tile displays all the services for the application. For each service, information such as the VM name the service is hosted on, associated IP addresses of the service and VM, traffic, and event summary is provided. Top workloads for the application displays CPU, memory, and the traffic volume. Let's now take a look at the flows for each of the services of the ERP application. Here, we see the application service dependency graph for the ERP application. This graph shows us how each of the services are communicating with each other, like Inventory DB and Core CDS are communicating with each other, but Inventory DB is not communicating with any of the other services for the ERP application. Service dependency graph also displays which services are communicating with external sources. The dependency between the services can be viewed with respect to data usage or latency. To view the hop-by-hop path of a particular flow, we select the link between the services of interest. Then we select a flow and view it in the topology. CV-UNO arguments the topology view to show both the physical network and the virtual infrastructure. We can see the exact hop the flow has traversed through from the source VM to the destination VM. Overlaying the application onto our topology view shows us how the virtual and physical infrastructure is utilized by the application. In conclusion, we have seen how applications are seamlessly discovered by CV-UNO, providing application context to the networking infrastructure, thus enabling users with proactive risk analysis of their critical applications. Thank you for watching.